In this problem, a wooden beam hangs over a ledge, and we're asked to find how far a person can walk out past the ledge without tipping the beam. In order to solve this problem, we'll need to identify all forces and torques present and apply the conditions needed in order for an object to be in static equilibrium. These are that the sum of all torques and the sum of all forces both must be equal to 0. We are also told that the beam is 14 meters long. We are told its mass, the mass of the person, and how far the ledge extends. The first step is to determine what forces are acting on the board and where exactly they are acting in relation to the pivot point. The pivot point is the edge of the cliff. Because the board is 14 meters long, we know that the distance between this edge of the board and the pivot is therefore 8 meters, or the length of the cliff, and the part of the board that extends past the cliff is 6 meters long. The forces acting on the board in this situation are the gravity force acting at the center of mass of the board, which is halfway between the length of the board, which in this case will be 1 meter to the left of the pivot. The normal force on the board from the person, and the distance away from the pivot is what we want to find. And the third force is the normal force acting on the board at the pivot point. Because the board is just about to tip, we can assume that this portion of the board here is no longer in contact with the cliff, so we don't have to worry about any normal forces here. So, to summarize, we have the force of gravity acting on the board 1 meter away from the pivot, the normal force between the board and the cliff acting at the pivot, and the normal force between the board and the man, and it's acting at some unknown distance away from the pivot point. Ultimately, we want to solve for the unknown distance between the pivot point and the normal force from the man, because that's going to be how far the man can walk out past the edge of the cliff without tipping the beam. To find this, we will balance the torques. The torques present in this situation are the torque due to the force of gravity acting on the board and the torque due to the normal force acting on the board from the man. The normal force from the pivot does not supply a torque because it's acting at the pivot. Using the right-hand rule, we see that the torque produced by the gravity force causes a rotation in the counterclockwise direction. So, by convention, this torque is positive. Conversely, the torque produced by the normal force from the man produces a rotation in the clockwise direction, so by convention, this torque is negative. We then write out an expression for these torques using the definition of the cross product, and we find that the gravity acceleration cancels, and we arrive at this expression here, which involves the unknown distance that we want to solve for. We solve that equation for x, the distance past the cliff, plug in the numbers that are given in the problem statement, and find that the person can walk 1.5 meters past the ledge without tipping the beam.